This is homework 8.4. It says U.S. Mint manufactures dollar coins so that standard deviation is 0.039. The accompanying list contains weights of dollar coins manufactured with new process designed to decrease the standard deviation, so it is less than 0.039. So we have this summary, N16, the mean and standard deviation, and it says 0.05 significance level to test a claim that the sample is from a population with a standard deviation less than 0.039. So we have the claim is standard deviation is less than 0.039. Okay. And then they also have here, so we have, well, they already gave you this. So null hypothesis is equal to 0.039. And then alternative hypothesis is less than 0.039. So this is left tail test. And this is case what? 304, okay, left tail test. Now, they already tell us that p-value is 0.0208, but 0.0208 is less than the alpha, which is 0.05. Since p-value is less than alpha, what we do, we reject the null hypothesis, right? So this makes case 3. So final conclusion would be sufficient evidence to support the claim. Is that right? Claim of what? Sigma is less than 0.039. So what they asking here, what would we conclude a null hypothesis? Because we're going to reject the null hypothesis because p-value is less than the alpha. So we're going to reject the null hypothesis. Okay. What should we conclude about the original claim? So, original claim is sufficient evidence to support the claim. So, there is sufficient evidence to support the claim of that, population standard deviation less than 0.039. Okay. Now, so this is a new mint. Okay. So, new process is better than the old process, okay? So here, what do these results suggest about new meaning process? Because it varies less. Based on the result, the new meaning process is effective or better, appears to be better than the old method, since there is evidence that weights of coin produced by process, it varies less. Well, significantly low variance, that's possible, not, yes. Significantly higher, significantly lower variance, it varies less, okay? It's more uniform, right? Okay, let's look at question number 2. Question number 2 says, the piston diameter of certain hand pump is 0.5. The manager determines that the diameters are normally distributed with a mean of 0.5 and standard deviation of 0.004. After recalibrating the production machine, the manager randomly selects 22, n equal 22, and determines that standard deviation is 0.0036. Is there sufficient significant evidence for the manager to conclude so standard deviation has decreased? So, in other words, claim standard deviation is decreased. Decreased from what? From point, the old one was 0.004. Okay. So is 0.0036 is a new standard deviation. So can you conclude is less than 0.004? So this is case 304. Number 2, null hypothesis is then sigma is 0.004. And then alternative hypothesis is same as the claim 0.004. Okay, so this is our left tail. Okay. Now, so test statistic is we call chi-square, which is n minus 1 times s squared divided by sigma square. So n is how many? 22, so 21. S is given as, it came out to be 0.0036 squared divided by 0.004 square. Okay, so this is, if I put that in the calculator, well, I'll just show you right here. So 21 times 0.0036 square divided by 0.004 square. Okay, that gives me 17.01. Now, if I do traditional, so this is, if I do traditional method, what that means, we have critical value. It's a left tail test, so this side, this is critical value. This area alpha is 0.10, so this area is 0.10. So how to find this critical value? You go to calculator that I ask you to install. Go to program. Do you see that number 1 inverse chi? Hit enter and then hit one more time. What is area to the right? So area to the right is 0.90. So I'm going to put 0.9. Okay. And then what is degree of freedom? 21. Okay. Then this critical value is 13.2396. Now, our test statistic 17.1 is outside of critical region. Okay. So if I call this step 5, since our test statistic is not in the critical region, test statistic is not in the critical region, what do? Fail to reject null hypothesis. Okay. So that makes, what is it? It was supposed to be case 304, but now it's case 4. So what is final conclusion? Number 7, final conclusion is not sufficient evidence to support the claim. To support the claim of, what was the claim? Sigma is less than 0.004. We're not going to support that. Now, if you use p-value method, p-value is the area from test statistic. So this one is now 17.01. It's left tail, so we have to get this area. So what is this area? This area becomes p-value. Okay, so that area, to find that area, you go to second bars, and you go to do you see chi-square CDF? There's a number 8. Okay, and lower is 0. Okay, and upper is 17.01. Degree of freedom is 21. And then you hit one more time. So p-value is actually what? 0.2895. So since p-value is greater than alpha, because alpha is simply what? 0.10. Okay. And then, so you fail to reject null hypothesis. Okay. And question is the last step is the same thing. So now let's answer these. So null is sigma equal to 0.00. Oh, it's right there. Alternative is sigma is what was it? Less than, right? Less than 0.004 because it was left tail test. And then chi-square, what's chi-square? I see it right there. Test statistic. 70. Ooh, they want 3 decimal. So I got it. Was it 17.1? Let me just calculate this again. They used to ask for 2 decimal now. Oh, it's just a 2 decimal. It ends with 17.01. So I'll just enter 17.01. Okay, all right. And then p-value. Now, what was p-value? I had p-value right here. Right here. So now that p-value is they say 3 decimal. So 0.290, isn't it? Okay, so 0.290, 3 decimal. Okay. So now, since p-value is greater than significance level, we do not reject the null hypothesis. And what's the final conclusion? There is not sufficient evidence to support the claim. Okay. All right. Now let's look at question number 3. Oops. Question number 3. Assume that Friday morning taxi cab rides have times with standard deviation, sigma equal 10.2. A cab driver records time of ride during the Friday afternoon, this time, period, and obtains n equal 13, x plus 17.4, s is 12.5. Use point 10 sequence level to test a claim that these Friday afternoon time have greater variation than Friday morning. So, number one, claim the sigma, the Friday afternoon, has greater variation than Friday morning. What is Friday morning? Is 10.2. Okay? So this is, again, case what? 304. Null hypothesis is sigma equal 10.2. Alternative hypothesis is same as the claim, which is right tail test. So now test statistic is n minus 1 s squared divided by sigma squared. So n equal 13, so it is 12. S is 12.5 square and 10.2 square. Okay. So in the calculator, 12 times 12.5 square divided by 10.2 square, right? So I have 18.0219. Now, this is a right tail test. Okay, so I'm going to do traditional and p-value. Okay, this is traditional method. Okay, now traditional method, you need to find critical value, right? Critical value. But this is right tail test. Okay, so you have to go to alpha equal, what is it, 0.10. So this side is 0.10. This area is 0.10 because it is right tail test. Okay, so now, so you need to find critical value, right? So to find critical value, you go program inverse chi. I'm going to clear everything. Program inverse chi. Now, what is area right? Area right is 0.10 because it's right tail. So 0.10. And then what is degree of freedom? 12. 13 minus 1. So this one's going to take a little time because TI-83. Yeah, it's still going. Yes, 18.549. Now, our test statistic is 18.02. So this is not quite inside. Okay, it is outside. Now, since it is outside, what do? You fail to reject null hypothesis. Okay, so this is what? Case 4. Final conclusion. Not sufficient evidence to support the claim of variation is greater than what? 10.2. Okay. Now, if you use p-value method, p-value work with test statistic. So this point is test statistic. It's not critical value. 18.0219. If you go all the way to the right, what is it? 999,999, right? Okay, let me draw a bigger picture, okay? Here. If you use p-value method, I'm going to just do it here, this area, right? So this is test statistic, which is 18.0219. Over there is what, 999. We use that. You can actually more 9 is okay. So this is the area, which is the p-value. Now, how to find the area? You go to second. Oh, this calculator doesn't have it, so I have to use this more advanced calculator here, TI-84. When I clear everything, go to second bars. You go to chi-square CDF, and then lower is 18.0219. And then upper is, like I said, 99999. Some people say, well, 10 to the 99, but it's okay. As many as 9 is okay, but 6 or more. And degree of freedom is 12. And then paste. One more time. So it is p-value, this area is what? Let me write here. 0.115. Okay? So we have p-value. Well, this is step 5 and 6. Since p-value is, what is alpha? I don't need that. P-value is greater than, barely greater than 0.10, because p-value is 0.115. So same conclusion, okay? So this is same conclusion. So now let's answer it. So null is equal to 10.2. Okay. And then this is greater than 10.2. Okay, check answer. And then test statistic, I have it. So test statistic is round to decimal is 18.02. 18.02. See, they asking 2 decimal now. Okay. And then p-value, where is the p-value? I said 0.115. Okay, here p-value is 0.115. 0.115. Okay. And then, so here we failed to reject the null hypothesis. There is not sufficient evidence to support the claim. Okay, of sigma is greater than 10.2. All right, that was question number 3. Now let's do question number 4. Wow, question number 4. Question number 4. Test the given claim. Assume that a simple random sample size from a normally distributed population use either p-value or traditional. Company use new production method to manufacture aircraft altimeter. I mean, where how high is the airplane? This is Earth. How high is the plane? How high is the plane? Very important. How high is the plane? Altimeter. Okay. How high? Okay. It's very important. Now, so use 0.05 significance level here. Test claim the new production method has error with standard deviation greater than 32.2. So here, so claim their new altimeter standard deviation is greater than 32.2. So this is again case 304. Null hypothesis is 32.2. Alternative hypothesis, same as the claim, which is the right tail test. Okay. Now, test statistic n minus 1 s squared divided by sigma square. How many altimeter? Oh, we don't have that. We have a data here. So now we need to find the standard deviation of this. Okay. So you go to stat, summary stats column, bar 1, all we need is standard deviation, okay? What is that? 57 point. So let me just move it over here. What is it? S is, let me just copy that value. S is 57.824906. I'll put the whole thing there, okay? 824906. Okay. So now this is n minus. So what is n, by the way? How many? So there are 12 of them, right? Do you see that? There are 12 of them. Okay. So, okay. So now, put it over here. So 12. So 12 minus 1 is 11. S is 57.824906 squared divided by 32.2 squared. Okay. So calculator out here. Turn it on. It's turned on. 11 times 57.824906 square divided by 32.2 square is 35.4743. Okay, so now they said either what tradition. I'll do both. Okay, so here this is a traditional. This is p-value. Now tradition is you need to find what? Critical value, right? This is right tail test. This is critical value right here. What is the area? Area is 0.05. And the degree of freedom is 11. Okay, so now you go to program inverse chi. Hit one more time. Area right is 0.05. Degree of freedom is 11. Okay, this one takes a long time, you know, so I'm gonna just exit. How about do this? The other calculator here. Okay, I'm gonna clear that, and then program inverse chi. One more time, area right is 0.05, and then degree of freedom was 11, right? So it is 19.6751 like this. But our test statistic is in the critical region, isn't it? Because that is bigger than 19.675. So this step is step 5. So step 6, now we can reject the null hypothesis. So this is case 3. What case 3 says? Sufficient evidence support the claim. Okay. To support the claim. Claim of what? Sigma is less than or greater than, greater than 32.2. It varies more, so it's not very good. They need to fire the manager. It's not good. Now p-value again. Let's say step 5. Now p-value, you work with test statistic, right? So this is right tail. So 35.474, 9999999. If it's left tail, you start from 0 to 35.47, but it's right tail. So p-value is simply the area, isn't it? Is the p-value. Now, so you go to this time, to find the area, you have to go to second bars. You need to go to chi-square CDF. Oops, chi-square CDF. So lower is 35.475. And then, 45.475. And then upper is 999, as many 9 you want. And degree of freedom is 11. Okay, why do that? Down. Okay, so hit one more time. So this is, p-value is 2.06826 blah blah times 10 to the negative 4. That means 0.0002068. Okay, so we'll stop there. Now, so what is null and what is alternative? Null is equal, alternative is greater than, here. Okay, and then test statistic, we have it there. What is it? 35.474. So round to 2 decimal, 35.47. Okay. Now, what is critical? I see they ask critical value. See here, critical value, right here. I wrote it there. Okay. So then when you write why they have critical value values. If it's a plural values, you have 2 critical values, lower side and upper side. But this time it is just right tail, so you just need 1. Now, how many decimal? Round to 2 decimals. So what is it? Critical value is what? 19.68 to round to 2 decimal. So 19.68. Okay. Check answer. Very good. And then, since the test statistic is in the critical region, or greater than critical value, since test statistic is greater than the critical value, we're going to reject the null hypothesis. So there is sufficient evidence to support the claim of the standard deviation is greater than 32.2. Okay. Now, so it's not very good for the company, the variation of heights, for the same height, they give you different height. In other words, if a plane is say, what, 20,000 feet, okay, but the machine says, oh, it's 15,000 feet or 25,000 feet, when it's actually 20,000 feet. The variation too much, so it's not very good. The variation appears to be, okay, it is on the right side. Okay, our test is, it appears to be greater than the past. Well, great. So the new method appears to be worse because there will be more altimeters that have errors. Therefore, the company do something. What is it? Should take immediate action. Okay. All right. Now let's do the next question. Okay. Here, let me just bring it over. No, not that way. Okay. This is question number 5. Okay. Question number 5. The accompanying 200 Los Angeles commute times to test the claim that the sample is from a population with standard deviation equal to 19. So, this two-tailed now. So claim is standard deviation is equal to 19. So this must be case 1 or 2 for the final conclusion. And then null hypothesis is 19. Alternative hypothesis is sigma is not equal to 19. So this is two-tail. This is a good example for two-tail. So test statistic is n minus 1 s squared sigma squared. Do we have that? No, we don't have it. All we have is like 199 because 200 minus 1. And then what is the s? Oh gosh, we gotta find s from here. Okay, so you click StatCrunch. Then you're gonna find the standard deviation. So go to stats, summary stats, columns, highlight bar 1. What we need is standard deviation only. So compute. So I have standard deviation as 22.161082 squared divided by 19. Okay. So here. So clear, and then 199 times 22.161082 squared divided by 19 squared. So I get 270.7246. I think that's enough. Now, so traditional and p-value, okay? Okay. So now, traditional, okay? Now, so to traditional, we have, looks like this. We have critical value here, and we have another critical value. Why? Because it's two-tailed. Now, alpha is significance level is 0.01. So this area is half of that, 0.005. This area is half of that, 0.005, same thing, okay? So now what is critical value? Okay, so you need to go to this calculator. I'm going to clear. You go to program, inverse chi. One more time. What is the area right for this guy? 0.995. 0.995. Okay, what's degree of freedom is 199. Okay, so it is this critical value is 151.3699, so I can say 270. What is this critical value? So area is simply 0.005. So do again, clear, program, inverse chi, one more time, 0.005. That's area, right? Okay, and then degree of freedom is the same, 199. And then this critical value is 254.135. Now, our test statistic, this guy, is in the critical region over here, isn't it? Okay. So it's in the critical region. So what do? You reject the null hypothesis. Then must be case what? 1. Okay. What's case 1 said? sufficient evidence to reject the claim. To reject the claim of, what was the claim? Claim is sigma is 19, commit time is 9, variance of commit time is 19. Okay, so now let's do p-value. Now p-value, now our test statistic is the other side of critical value. Do you see that? So you go from this point is test statistic to 70.7246 all the way. What's out there? 9999999 9999999. Okay, so this area is the p-value. How to find the area? You go second bars, go to second bars, go to chi-square CDF. Now, what is lower? 270.7246. And then I got already a lot of 9 there. What is degree of freedom? 199. And hit one more time, you get p-value, very small area, is 5.40189 times 10 to the negative 4. You know what that means, right? 0.0005401, like this. Okay, so now since p-value is less than alpha, which is 0.01, oh no, this is two-tailed, so p-value is 2 times the area because it is two-tailed. Don't forget that. So p-value is this guy times 2. So I'm going to that guy times 2 is 0.00108, 0 like this. So p-value is still, p-value is less than alpha. Alpha is 0.01. Okay, so p-value is less, reject the null hypothesis. So same thing, case 1. It should same whether you use traditional p-value. So let's answer it. Okay, now, so null, I'm going to start from there. Null is sigma equal to 19. And then alternative is not equal to 19 then. Okay, right? Now, what is test statistic? We got 270 points, so round 2 decimal, 270.72. Okay, right? P-value, oh my God, P-value is here, 0.00. Now, 3 decimals, so 0.001. 0.001. I hope this is right. Okay, and then what do? You reject the null hypothesis. There is sufficient, this case 1, so there is sufficient evidence to reject the claim. Okay. Now, so reject the claim of what? Well, the standard deviation is equal to 19, but that's not true. Okay, so does the 200 noise commit time satisfy requirement of this one? Okay. No, because sample is not, it says simple random sample, isn't it? Okay. The use the parameter, okay. Determine the test 200 commit time, okay. Yes, because sample can be reasonably assumed to be a simple random sample and the distribution of data is somewhat close to being symmetric. No. Yes, because simple sample can be reasonably assumed to be simple random sample and the sample is large. That is the answer. Oops, wait a minute. It is one of the answers incorrectly. Just a minute. Here. Does the distribution 200 commute times satisfy the requirement hypothesis testing? The requirement is simple random. Population has to be normal distribution. Because simple can be assumed to be sentient as one mode and does not include any outlier. No, because there is evidence of does not have a normal distribution. It has to have, population has to be normal distribution. Okay. Let me look at here. Let me see. How about to be normal distribution has to be histogram, right? Okay. Aha. This doesn't look like normal distribution. Do you see that? We have you have one outlier, 141 there. Okay, so it has to be normal distribution population. So I think it is no, not that one. No, because evidence the population does not have a normal distribution. Okay, in other words, the population when you draw a histogram, it should be approximately normal, but it's not. Okay, all right. Go to the next question. Oh. Which of the following is not property of chi-square distribution? The chi-square distribution different for each number of degree of freedom, which is true. The mean of chi-square distribution, no, that's not true. Mean is not 0. Okay. All right. Okay, that's the end of it.